Okay, in these two videos, what we're going to try to do is practice drawing contour diagrams by hand. Now, we can get better pictures with technology, but we're not going to get better understanding with technology, and I just want to make sure we know what's going on and what we would have to do in order to start graphing stuff. So the first one I picked a cylinder, z equals x squared. What we're always supposed to do to make contour diagrams is start picking some z values that we think are appropriate. Now, I'm not going to pick any negative z values because x squared is at least 0. So what I'm going to do, I think, is just, how about if we just pick 0, 1, 2, 3, and 4. I think that should be fine. Now, what we're supposed to do in general is solve enough so that we can see what to draw. What I'm going to do is just take the square root of both sides. So I'm going to write down x equals plus or minus the, here we go, come on, the square root of every one of these numbers. And just see what we think we're going to get. Now remember, contour diagrams get graphed in the xy plane, so I'm just going to have my little xy plane sitting here. I guess I can put a y here. Not so happy about that. Now the first thing I'm supposed to draw is x equals plus or minus the square root of 0. Well, that's just x equals 0, and that is going to be just the y-axis. And what I'm going to do is right at the y-axis, I'm going to write down a little z equals 0, because that's what it is. The next thing I'm supposed to draw is x equals plus or minus the square root of 1. Well, that should be 1. So I'm going to draw a contour here at 1, right? Remember, and this is when z equals 1, and a contour at negative 1. Like this. And remember, that's also height z equals 1. We'll talk about what this looks like physically in a couple minutes. The next thing I want to do is draw x equals plus or minus the square root of 2. Well, the square root of 2 is about 1.4. So what I'm going to do is put 2 down here and put negative 2 back here. And I need to draw a contour at about 1.4. So that's going to be like this. I'm going to put a little z equals 2 here. I'm going to draw, I think this needs to go a little bit further. How about that? A contour right here. And this is also at z equals 2. The next thing I need to draw is x equals plus or minus the square root of 3. Well, the square root of 3, I think, is something like 1.8-ish, right? So this is about 1.4, so I'm going to go closer here to 2, so it's going to go like this. This is going to be what we get at height equals 3. Over here, I'm going to get at negative 1.8-ish. I'm going to get another line, and this is going to be at z equals 3. And the last contour we decided to draw here, I guess we can sort of carry these further, is x equals plus or minus the square root of 4, which is x is equal to plus or minus 2. So this is going to look like this, and like this. And that's enough of a contour diagram that we can draw by hand for this particular thing. Now, two things about this. We can tell which variable is missing when we look at something like this, even if we don't have the formula. Because if I go on any contour, like this one contour here, and I change y, the value of the function does not change. And you notice that's true no matter where I go. If I go to a contour and change the y value and just the y value, the value of the function doesn't change. That means the function in this case was missing a y, and sure enough, it is missing a y. One more thing about this, maybe two. If I were to have this surface and I were to walk from west to east on this, what does it look like? Yes, I see that z goes from 4 down to 3, down to 2, down to 1, down to 0, and then back up, right? The section, that's the nice thing about a contour diagram, is you can tell what the sections are going, the cross sections are going to look like. The more math you take, the less they'll call them cross sections, but I'll call them sections. A section here, remember that's a vertical chop, is going to be a parabola. Every single time, no matter where I chop like this, I'm going to get a parabola. For what it's worth, no matter how I chop like this, I'm going to get a line. The reason for this, by the way, is because this is just a taco, right? This is our infinite taco, and if I try to just draw our infinite taco so I can see what's going on, remember that looks like this, that looks like this, that looks like this. You can see the parabolas if I chop one way, and then you can see actually the horizontal lines if I chop the other way. So that's how you make a contour diagram, and those are pretty much the two sort of things we're going to be doing a lot with it. We're going to be using it for sections, we're going to be using it for shapes, and that's it. So that's example number 1 of finding a contour diagram by hand.